Welcome to chapter 4. This is on USB design interface for the microcontroller. So here we'll be looking at how do we design the USB programming interface. So we have these two pins A7 and B7 and A6 and B6, which are there for D minus and D plus. Let's label them first. So let me label this D minus itself. One neat thing about KiCad or KiCad, how you want to pronounce this, uh, it comes with differential pair routing. That takes majority of the headache away from the designer with respect to differential tracks. What differential track means is the track which would be running simultaneously with respect to each other, which would have equal distances between them so that they are impedance matched. They do not interface with each other's frequency and the waves. That is called differential tracking. So D minus and D plus are uh, already put on the USB. So now we need to connect those D minus and D plus here. So we'll just double check before we place it on the microcontroller. 3.6 is plus USB data plus. So move that here, and this gets moved here. This gets moved to 3.7. So this is what it is, routing between D plus and D minus. Again, secondary caution, this is not always required because we are dealing with power pins which cannot work beyond 3.3 volts, right? USB transceiver are designed built in based on USB 2. The cannot be connected to resistors in series when they're used, right? And also here they have said that internally use 3.3 as IO power. So the high level of the input and output can only reach voltage 3.3. So this cannot exceed 3.3 volts. So what we need to take care here is make sure that we have that particular 3.3 volts fixed. How do we do that? Either you can go with let's say uh, a circuit which can stabilize USB data delivery, right? Like a data protection circuit or something, or a quicker way is using Zener diodes. 3.3. So we have two Zener diodes here. Both work in similar fashion. This one comes with 450 picofarad capacitance. This one doesn't have or doesn't mention any stray capacitance. So power rating is 300 milliwatt. This power rating is uh, again 500 milliwatt. So I would go with this because it has higher power rating, so it might be able to handle much more current, right? So this has a package of TO35. So we'll go ahead and put those two. This we are just keeping it for the namesake, we'll not be connecting it. So DO35 This is mini, sorry, it is not Devo35, it is mini MELF package. So we have selected mini MELF package here. We'll place two of them. Take a ground to ground here. Put it here, right? So D plus and D minus. They go one each. So strictly speaking, this is not always necessary. I'm just designing it so that we have some precaution. This would be 3v3. So, so that is what we might have to do with the USB route, sorry, USB tracks. So although I have not drawn direct tracks, I have connected this D1, D minus and D plus with 3.7 and 3.6, and also with respect to these two Xenors. So that ends chapter 4.